So we're going to go over synthetic division. Why divide in the first place? Let's say I have this polynomial, okay? This is a cubic function. It's to the power of 3. So in fact, it has 1, 2, 3, 4 different terms, we should say. So when we go to divide something, there's a purpose to it. When you go to divide, the point of it, and I'll kind of draw it on the side here, cubic does this pattern, okay? It goes like that if it's a positive, and this is positive, and if it's negative, it would technically like go that way, but we have a positive one, so we're just going to look at this one here. When we do this, we're trying to get factored, so we want to actually put it into some type of factored form. So we're going to have 1, 2, 3, and it'll be like x minus, you can call them any variables, you can call them k, a lot of times they call it that, so I'm going to call it x minus k1 and x minus k2, I should have probably did 1, 2, 3, whatever it is. Each of those is a 0. It's where it crosses the x-axis. And if you remember, factoring for a quadratic is the same idea. This is just another form of factoring. We can't use quadratic formula because this is not a quadratic. This is a cubic. So division, and a lot of times they use long division for this. This is how we go about factoring polynomials that are kind of larger than quadratics. Okay? How do I know what to divide by? Well, in fact, the way to do that is you have to find a factor of this, a factor that creates a 0. So it's kind of a guessing game. One of the easiest ways to create a factor, or one of the ways that tends to work, is if you take the coefficient in front of the first term and multiply it by the constant at the end. Whatever that makes sometimes is a factor that is a 0. So 1 times, what's the coefficient there? 1. Okay, let's try 1. So I'm going to quickly write it out and see if this would work for us. Does this create a 0? That's what we're kind of asking ourselves. I want the color blue. Why can't I get the blue? So, thank you. Okay, we're going to do green. Oh, finally, here we go. Okay, so if I put 1 in here, 1 cubed is 1. 1 squared is 1 times 2, so we have 1, we have a 2. Negative 6 times 1 is 6 plus 1. Okay, so 1 plus 2 is 3 plus 4, negative 6. That actually didn't create a 0. It needs to create a 0 when we do this. So that was not helpful. Let's take them all away. Let's try, and we should actually try both the positive and negative version of it. So if I did negative 1, let's say we had negative 1 in here. Negative 1 cubed would be negative 1. That'd be positive 1, so it'd be plus 2. This would be plus 6, and this will be 1. Again, we're going to be 8, 9, minus 1. Thank you for that. Didn't work. Okay, let's try positive 2. 2 times 2 times 2 is 8. 2 times 2 is 4 times 2 is 8 again. This would be 12, and this would be 1. 8 plus 8 is 16. Plus 1 is 17, minus 12. That doesn't work. Let's try negative 2. Negative 2 is negative 8 here. Negative 2 would be positive 8 here. Let's cancel out. This will be positive 12 and 1. So that's not a factor either. This one have a remainder?
Yeah.
It does. Okay. We could find a whole, we could keep going with this and try to find one, and I really should. So I'm going to pause right now, and then I'm going to find one so we don't have to go through this whole process. After much deliberation, we realized we picked one that does not have a nice whole value. It's actually like decimal values and fractions. Not a big deal. So our x values are going to be decimals, so we're not going to find an actual x value. What we're actually going to do is just go through the practice of synthetic division. So I'm going to take a value. We're going to take negative 2 for this, okay? So the idea would be like, if we did something like this, we'd say x minus negative 2. That would be our brackets. And I think I like the more. That's better. X minus negative 2. That's going to be one of our factors, okay? So think of it like we're going to be dividing this whole thing by x minus negative 2. Synthetic division is kind of set up with an upside down division sign. You know, our division signs tend to look like this. Think of like you've flipped it on your end, and it's going to go like that, okay? So this is for our synthetic. And what you're going to do is actually take each of the coefficients of every term and write them in as values here. So I have coefficient 1, I have positive 2, I have negative 6, and I have positive 1. And then finally, actually, sorry, since I said we're going to do negative 2, it would technically be plus 2 in the brackets. If we brought negative 2 over here, we are then going to, there it is, we are going to add, okay? So, synthetic division can be done two ways. We're going to show you this way. If you take the opposite of what's in that bracket and put it here, so because it says plus 2, if we take negative 2, which is essentially like setting this equal to 0, what x would be equal to, if we take negative 2, we are going to add. So keep that in mind. If you did the opposite and you took plus 2, you could subtract. You can do either of them as you like. The process is actually far simpler than long division now. We bring down this coefficient, so we have the value of 1. I then take this negative 2, okay, and change that color so I can get faster at it. Great. I'm going to multiply it by negative 2, that's this value here, and put it as another value here. So negative 2 times 1, yeah, put it here, negative 2. And now we add, well, what's 2 plus negative 2? 0. Great. Now we multiply by negative 2. What do we get? We get 0. 0 times anything is 0, right? We add the two values, negative 6 and 0. That's going to give us negative 6. We then multiply by negative 2 again. That becomes 12. Great. And then we add the 2 and we get 13. So 13 is our remainder in this case, okay? So now when we go to write this function out, we've semi-factored it. We have f at x is equal to, we're going to write what we divided by, so x plus 2, because remember it's the opposite of that negative 2. Each of these represents the new coefficient in front of a term. So because we factored through once, the cube, or the power of 3, is disappeared. So this highest coefficient is actually x squared. This is x to the power of 1, and this is a constant, yeah. So you could kind of write it like x squared, okay? And again, you write the brackets beside each other as if they're being multiplied in, okay? And then, because it's 0x, do we have to write it in? No, we can just write minus 6. And then finally, this remainder, because it's positive 13, we just say plus 13 after that. And that's our factored form of this, okay? Again, it didn't factor super nicely, but this is our synthetic division. That's a fast way of doing it. Reiterate what we said. I'm going to quickly put the synthetic division on a new page here. So again, we write it upside down. And remember we were talking about x plus 2 in brackets. Well, instead of making it what x would equal, if we set it equal to 0, it would be negative 2. Let's just take this value. Let's put plus 2 here. If we do that, we're going to subtract when we do synthetic division, okay? The coefficients, I think, were 1, negative 2. Oh, wrong page. That's
1,
right.
2,
1 positive 2, negative 6, and 1. Okay, so let's run the synthetic division the exact same way we had done this. We bring the 1 down, we get the value of 1 here, we multiply by positive 2, that's a weird multiplication, so we get 2, and when we subtract the 2, we get 0, so far the coefficients are the same. We multiply again by our 2, still 0. When we subtract, we get negative 6. And then when I multiply by 2, I get negative 12. Well, 1 subtract negative 12 is the same as adding. We get 13. And lo and behold, this is actually the exact same thing we had done before. So we would have our x plus 2. Right? We still write it that way as if it was in brackets. And then we get x squared. You could say 0x if you want, minus 6. And then plus 13. 13 is the remainder. So those two things end up being the exact same. Does that make sense? Okay, great.